Hello chemistry students and welcome to lesson 3.09 where we're going to talk about molar mass of compounds. Back in module 2 we talked about molar mass of elements. Now we're going to build on that after having learned about compounds and apply those principles to that situation. Before we do that, let's just take a moment to mention the standards that we are going to be focusing on. There are some common core standards that will be addressed throughout this lesson. If you'd like to read over these, please pause the video at this time and take a look at those. You can also access these in the course information and then click on standards and you can read all of the common core standards there also. Specific to this lesson, our objectives will be to calculate the molar mass of a given compound, and then we will use that to help us determine empirical formulas from given data. Now, as I mentioned a moment ago, we do need some of lesson 2, or module 2, but we also need some lesson 3.08. Okay, but first, let me just mention that we do need to make sure we're comfortable with 106 and 204. From 106, we were dealing with unit conversion, so again, we will be doing some dimensional analysis in this lesson. We also need from 2.04 how to determine the molar mass of elements, and then be able to convert between moles and grams. And we're going to apply all of those concepts here in this lesson. And finally, we also need lesson 3.08, naming compounds. So again, we're starting to get to the point where we're going to take a lot of what we've been learning up to this point and kind of start putting it all together as we finish up module 3 and move into module 4. Okay, so be sure you're feeling comfortable with all of those topics before you continue into lesson 309. And if you need, please go back and watch some videos, do some more practice problems, attend a tutoring session if you need. But we do want you to be comfortable with that material before we attempt 3.09. Alright, so a little understanding here about molar mass of compounds. Alright, the mass values on the periodic table, remember, represent the mass in grams of 1 mole of the element. And again, just going back to lesson 2.04, remember that 1 mole of any element means we have 6.022 times 10 to the 23rd atoms of that element. So for an example, if somebody asks you what is the mass or the molar mass of calcium, you'd go to the periodic table and you'd simply say the 1 mole of calcium is 40.078 grams. So in other words, 6.022 times 10 to the 23rd atoms of calcium would equal 40.078 grams. So in that lesson back in 2.04, we used that relationship to convert atoms to moles and then moles to grams. And then of course we went the other direction too. We started with grams, converted it to moles, and then converted the moles to atoms. Well, that same principle works when we're talking about compounds. 1 mole of a covalent compound equals 6.022 times 10 to the 23rd molecules. 1 mole of an ionic compound equals the same thing, 6.022 times 10 to the 23rd. But remember, we called them formula units, and we learned that earlier in module 3. Okay, so it's the same principle. We're just now going to apply it to the compounds instead of just looking at individual elements. All right, now the second part then is to incorporate those concepts as we look at these formulas. Okay, remember up to this point when we've talked about formulas and the subscripts, we say that those subscripts tell us the number of atoms in that particular molecule or formula unit. Well, it also can be used to interpret the number of moles. So if we look at the example here, we have Ca and then parentheses ClO3 and then the close parentheses 2. The name of that compound, Ca, is calcium. ClO3 is one of the polyatomic ions that you need to have memorized, and that is chlorate. So this compound is called calcium chlorate. Now, if you were asked how many atoms of calcium there are, well, we would look at the subscript. There's nothing there. Just like in math, if there's nothing written there, it's assumed to be a 1. And when you see X in math class, you know that means 1x. Same thing works here. So we have 1 calcium. If we are asked how many chlorines, again, the subscript is 1, but because of the parentheses, and then with a 2 outside, that means it's 2 times 1. So we actually have 2 chlorines in this formula unit. And then for the oxygen, we'd have to do the same thing. The subscript is 3, but we need to multiply it by the 2 outside of the parentheses. So it's 2 times 3, so we have 6 oxygens. All right, so again, that's kind of like a math problem there with a distributive property. That 2 distributes through everything within the parentheses. All right, so that's this line down here, the second line. We have 1 calcium, 2 chlorine, and 6 oxygen atoms. Well, for what we need to do with molar mass, we can also use those same exact numbers and interpret that as moles. We can say it contains 1 mole of calcium, 2 moles of chlorine, and 6 moles of oxygen. All right, so again, the same ratio, just using a little different interpretation. All right, so with that in mind, we can then, of course, determine the molar mass by simply multiplying the mass of each element by its subscripts. All right, so if we look at the example that we have here, we have SnSO4 So we grab our periodic table. If you haven't gotten one out, you might want to have one out to try some of the practice problems here in a moment. But Sn off the table is 118.7. Sulfur is 32.065. And oxygen is 15.99. Okay, so down here is all of the math. All right, when we look at the formula, Sn, there is nothing there, so it's a 1. Sulfur is 1 times the 2 outside the parentheses, so there's 2 sulfurs. And then for oxygen, it's 4 times the 2 outside the parentheses, giving us 8 oxygens. So now for our math, we have 118.7 grams per mole of the Sn, the tin, times 1 equals 118.7. For the sulfur, it was 32.065 times the 2, so the total there is 64.13. And then for the oxygen, we had 15.999 times 8 equals 127.992 grams per mole. So now we just simply take those numbers and add them together to get the grand total. And the molar mass for this compound would be 310.83 grams per mole of SnSO4. All right, so again, we take the mass of each element from the periodic table, multiply it by the subscripts to get how much mass comes from that element, and then we add those numbers together to get the grand total. So let's look at a couple examples together now. All right, so again, have a periodic table handy. All right, so for the first one here, again, we've got potassium permanganate is that polyatomic ion. So we're going to go to our periodic table, and we're going to look up the masses for each one of these. And then multiply by those subscripts. So potassium, when we go to our table, is 39.098 Now when we look at the formula KMnO4, we only have one potassium there. So that one will just stay, oop, there we go, 39.098. All right, for manganese, again, looking at the periodic table, we have 54.938. In the formula, we only have one Mn, so that one also will stay the same, 54.938. Okay, and then oxygen. All right, again, looking at the table, oxygen has a mass of 15.999. In the formula KMnO4, we have 4 of them. So that gives us 63.996. All right, and we simply add those together. And it gives you a grand total of 158.032. And remember, the units for molar mass are always grams per mole. Right? And take a moment and write that number down, because we will want to use that in our next practice problem. So make sure you have that written down, have it handy. We're going to use it here in a moment. Okay, now let's try the next one here. This one's got a little more to it, a few more elements in there. Alright, so let's start with the nitrogen. Just go in order. Alright, so off the periodic table, nitrogen is 14.007. Now in this case, we have NH4 in parentheses with a 3 outside of it there. So again, we have one nitrogen times that 3. So total, we actually have 3 nitrogens in this formula. So 14.007 times 3, and that's going to give us 42.021. Okay, next one is hydrogen. Periodic table tells us hydrogen is 1.008. Okay, and again the subscript there is a 4. Multiply that by the 3 outside. So 4 times 3, we actually have 12 hydrogens total. So 1.008 times 12 gives us a total there of 12.008 9, 6. And that's our hydrogen. Okay, now phosphorus. Phosphorus, looking at the table, the mass is 30.065. All right, and in the formula we only have one phosphorus, so that's not going to change. And then the last one there is the oxygen. And we did that one a moment ago, 15.999. And this time we have 4. Alright, so again that's going to be 63.996. And then we're going to add all of those together. And our grand total, 148, excuse me. .177. Again, the units are grams per mole. Alright, so again, write that down. 148.177. We will use that here in a moment. Alright, so now that's just to get the molar masses. Now again, just like we did back in lesson 2.04, we can then use that molar mass in a calculation, in a conversion. So the question here is, what is the mass of 1.70 moles of KMnO4? All right, so we're starting with the 1.70 moles of the KMnO4. All right, back on the last screen, that was one of them that we did the molar mass for, and I had mentioned write it down because we'll need it, right? So we're going to use it here for our conversion factor to get moles to grams. All right, because remember the units are grams per mole. Now we're going to need the mole on bottom, so that means we have 1 mole on the bottom. All right, and the reason for that again is so we cancel out the units. We got a mole on top, mole on bottom, they cancel out. So on top would be the mass that we just figured out, 158.032 grams. So we multiply by everything on top, divide by everything on the bottom. So in this case, 1.70 times the 158.032 divided by 1. And of course you could skip that part because it's not going to change the answer. And we would end up with 260, using proper significant figures, 269 grams of the KMnO4, potassium permanganate. All right, this time we're starting with the grams. We have 125 grams of the ammonium phosphate, the NH43PO4. Okay, so we're going the opposite direction this time, but we're still going to use the same conversion factor. So we have 125 grams, and we still use the molar mass as our conversion factor. All right, but again, this time, again, we're starting with grams, so to cancel out the units, we have to have grams on the bottom. So that molar mass we found out a couple slides ago is 148.177 grams, and that is in 1 mole. Right? Again, multiplying by everything on top, dividing by everything on the bottom to cancel out the units. So 125 times 1 divided by 148.177. And that would give us our final answer of 0.8444 moles of NH4 3 PO4 of the ammonium phosphate. Alright, so that's how we use molar mass to convert between moles and grams, and then of course back the other direction, grams to moles. Alright, now the second part of this lesson is dealing with empirical formulas and molecular formulas. Well, first, before we do any math, let's talk about what exactly they are. An empirical formula is simply the formula for a molecule that has the smallest possible whole number ratio of the elements in the compound. All right. We're going to actually do some problems here in a moment to determine the empirical formulas, but you basically can use the mass of each element to determine the ratios between them, and that's how you can write the formula. Okay. Now, a molecular formula, on the other hand, is the actual number of atoms that you have in that particular compound. So just for an example, let's say I have CH4, methane. Okay, and then I also have C2H8. All right, now CH4, I cannot divide that by any number and reduce it into anything smaller. Okay, carbon is 1. I can't divide that by anything to make it a smaller number. Okay, it has to be a whole number. So CH4 would be considered the empirical formula. All right. Now over here, C2H8, if I divided this by 2, I could reduce this, right? 2 divided by 2 would give me 1. 8 divided by 2 would give me 4. So since I can divide this by a whole number and reduce it to something smaller, this would be the molecular formula. Okay, so a simple way to think of it is the molecular formula is a multiple of the empirical formula. And the empirical formula cannot be reduced by any factor into a smaller whole number ratio. Okay, it is important that you remember it's a whole number ratio. We can't have half an atom. That just wouldn't work. So we don't do that. Okay? Alright, so there are some steps that we follow, and I kind of alluded to them a little bit just a moment ago. The first thing we do is we take the amount of elements in grams and convert that to moles. And we do that again by dividing by the molar mass from the periodic table. So we're doing exactly what we did a moment ago in the conversions, but we're just doing it like we did in 2.04 where we're doing just the element. Once we have the moles for each element, then we figure out which one's the lowest number out of the bunch, so to speak, and we divide all of them by that number so we get whole numbers. All right, after dividing them, again, you should have whole numbers. If not, then we need to make some adjustments. Okay, and generally speaking, this is what you're going to come across. If you don't have a whole number, you could have a half. If you have a half, then you multiply everything by 2 so that you do have whole numbers. The other scenario that you sometimes will get is 0.33. If you end up with something that has a 0.33 on it, then we multiply everything by 3. And again, to make sure we have whole numbers. All right. These two scenarios you don't typically come across, but you do want to be aware of them just in case you do. Okay, if you have a half, multiply everything by 2. If you end up with 0.33, multiply everything by 3. Most of the time, though, it will come out nice whole numbers for you. All right, so of course we need to do a practice problem so you can see what we're talking about here. All right, we got a sample of a compound that contains 22.1 grams of aluminum, 25.4 grams of phosphorus, and 52.5 grams of oxygen. And we need to determine the empirical formula. All right, so we got to take the information we're given, the 21.1 grams of aluminum. Then we have 25.4 grams of phosphorus. And finally we have 52.5 grams of oxygen. All right, so first thing we need to do, remember step 1 is to take the grams and convert them all to moles. And again, to make that conversion, we have to have molar mass. So we always want the moles on top in this case because we are starting with grams, so we need to divide by the grams to cancel out the units. The mass here is for aluminum from the periodic table, 26.982. Alright, so 22.1 divided by 26.982. That's going to give us 0.819 moles of aluminum. Alright, so now we got to do the same thing for the other two. So we take our phosphorus, and the moles would be on top. The molar mass from the periodic table is one we did a little bit ago, 30.974. So 25.4 divided by 30.974, and that gives us 0.820 moles of phosphorus. And then for the oxygen, one mole of oxygen is 15.999 grams. All right, and this gives us 3.281 moles of oxygen. All right, so step 2 is then divide by the smallest of all of them. So when we look at our three answers, the smallest one there is the 0.819, the aluminum. Okay, only by a fraction, but it is. So if we take the top one and divide that by 0.819, we're going to get 1. Okay, and that's why we do that, because we always will get 1 for at least a single answer. We do that here for phosphorus. And of course, that's going to be 1. Right? 0.820 and 0.819 are essentially the same thing there. And then on the bottom one here, 0.819. Okay, so when we do that, you end up with 4.007. And again, with carrying that out so many decimals, we can really just round it off and say 4. So those numbers then become the subscript in the formula. So our compound formula would be Al P O4, aluminum phosphate. And that would be our empirical formula. Okay? So those whole numbers that we end up with now become the subscripts in our formula. All right, and then the next thing we have to do is figure out a molecular formula. Okay, and remember earlier we mentioned that a molecular formula is just a multiple of the empirical formula. So the first thing we got to do is figure out the mass of the empirical formula. And then we will take the molecular mass, which will be given to us, divide it by the empirical formula to figure out what factor we multiply it by. Once we know the factor, then we just simply take the empirical formula, distribute the multiplier, or the factor, through the whole formula, and it'll give us a molecular formula. All right, again, let me walk you through an example of that so you can see it in action. All right, you determine that the empirical formula of a compound is NO2. In another experiment, you determine the molar mass of the molecule to be 92 grams per mole. Use this information to determine the molecular formula. Okay, so again, the first thing we had to do is figure out the mass of the empirical formula. So we take our N and we look up the mass on the periodic table, just like we did earlier. 14.007. There's only 1 in the formula, so that stays 14.007. We do the same thing with the oxygen. Again, our oxygen is 15.99. There are only 2 of those in the formula. So 15.999 times 2, and we get 31.998. And then we're going to add those together to get our grand total. And our grand total is going to be 46.005, and that should be a 6. Try that again. There we go, that's a little better. Alright, and remember the units are always grams per mole. Alright, so step 2 is to figure out our multiplier. And again, to figure out the multiplier, we simply take the molecular mass, in this case the 92, and we divide that by the empirical mass, which is the 46.0, and that would give us 2. Okay, that 2 is our multiplier. So we distribute that through the entire formula. In this case, it is the NO2. So our molecular formula is N2O4. And that would be our molecular formula. So again, you can see how it's just a multiple of the empirical formula. Okay, so that wraps us up then for lesson 3.09. At this point, if you have not already done so, please make sure you complete all example and practice problems in the lesson. If you still need some help, please attend one of the open tutoring sessions. You also have a review sheet in the Resource Center available for you. At the end of this assignment, there is a virtual lab that you'll do. And basically what you're going to do is you're going to actually write down your observations and conclusions and have that paper handy, because when you go and take the quiz for 3.09, it's going to refer back to that virtual lab and ask you some questions specific to that. So this is one time where you can definitely have your lab notes handy. So make sure you do take advantage of that. Write down everything you observe in that lab. And then again, you will be taking a quiz for this assignment, and it is located either in the assessment tab or the gradebook tab, whichever section you'd like to access it through. If you are taking this class for regular credit, at that point you can then contact your teacher for your discussion-based assessment and get that taken care of and wrap up Module 3. If you're taking a class for honors, then you do have the 309 honors assignment to complete, and we will see you around for that one. Hope you have a great day and enjoy 3.09.